So let's continue with 9.6. Here, question number 16. Read the question. Find the equation of the curve passing through origin. So that's the initial condition. What is given to you? Given that the slope of the tangent to the curve, slope of tangent equals to dy by dx. We know very well at any point. We know this. Okay. Now what is given to us? Slope of the tangent at any point is equals to, so you are given that dy by dx is equals to sum of the coordinates of that point, that is x plus y. This is given to us. Now this is the differential equation, remember. So we can solve very easily by linear differential equation, remember. So I can write dy by dx, here y is numerator, so in the numerator, so I'll take y on this side equals to x. Now it is in which form? It's a standard linear differential equation, dy by dx plus p into y equals to q form. It is in which form? Dy by dx plus p into y equals to q form. So here p will be minus 1, and what is q? That is x. Coefficient of y, which is minus 1, q is x. So first we get the integrating factor, which is integral of p with respect to x, which is here minus 1 with respect to x. So we'll get the e raised to minus x. This is integrating factor. And the solution is given by now. Solution is y into integrating factor, that is e raised to minus x, equals to inside the integral q. What is q here? X into integrating factor e raised to minus x dx. Now we just integrate this right inside expression. So this one as it is. Here what about right hand side? Integration by parts. Recall Liet rule. Algebraic and exponential. So this will be u and this will be v. We do by parts. X will come out, integral of e raised to minus x minus differentiation of x with respect to x into integral of e raised to minus x, that is e raised to minus x upon minus 1 the whole dx. Fine. So y into e raised to minus x, what is this? E raised to minus x upon the coefficient of x, which is minus 1, which are right in the front. Minus minus plus, and one more time you will do integrate, you will get one more minus sign. So it's like this, e raised to minus x upon minus 1 plus c. This minus will be plus, and one more time integration. So y into e raised to minus x equals to minus x into e raised to minus x minus e raised to minus x plus c. You can divide by e raised to minus x. So y equals to minus x, here minus 1 plus c upon e raised to minus x, that's e raised to x. So this is required general solution, remember. Actually you don't want this here. What you want? So no need to write in fact this. We want the curve that passes through the origin. Now we put just c equals to, we get the value of c using the condition given in the question. Now which condition you are given in the question? That it passes through origin, as it passes through 0 0, remember. It passes through which point? 0 0. So 0 0 satisfy the above equation. 0 minus 1 plus c into e raised to 0, and therefore c equals to 1. Fine. And therefore a required curve, or the solution required curve, is y equals to here minus x minus 1, and what c? That's 1. So plus e raised to x. That's a required curve here. Just placing the value in the above equation, you are getting this finally, remember. Question number 17, that's also good example. The curve passes through 0, 2. That's the initial condition. What is given to you? Given that sum of the coordinates of any point on the curve. So you are given this. Given that at point x comma y, at any point x comma y, sum of the coordinates x plus y here exceeds the magnitude of the slope of the tangent. What is the slope of the tangent? dy by dx to the curve at that point by phi. These exceed by phi. So if I want to make the equal, I need to write plus 5 here, remember. I repeat, what is given to in the question? The left hand side expression, these exceed by 5. So if I want to make the equal, I need to write the plus 5. Now this is a differential equation. Okay, so we just express in the standard form. So dy by dx, y will be on the other side. So minus y, and what we'll get here? Phi on this side. So x minus phi. Fine. Is this correct? Just have taken y on the other side, phi on this side. Now it is in which form? This is nothing but in dy by dx plus p into y equals to q form. It is in this form. This is a standard linear differential equation. And therefore p will be minus 1. And what is q? That is x minus phi. Okay, now integrating factor. Now I don't think so this is difficult for you. E raised to integral of minus 1 with respect to x. That's e raised to minus x. That's required integrating factor. And now solution. Solution is given by which formula? You know the solution here. Solution is y into integrating factor equals to, inside the integral q. What is q? That is this expression. X minus 5 into e raised to minus x dx. Now we integrate right hand side expression. Let's integrate RHS. So if I integrate RHS here, y into e raised to minus x as it is. There we use by parts, remember. You know it's a combination of algebraic and trigo. So x minus 5 will come out. This is e raised to minus x upon minus 1 minus inside the integral derivative of this, that's just 1, e raised to minus x upon minus 1 whole dx. I have dropped one step, remember, you can show that step. So here minus x minus 5 into e raised to minus x, minus minus plus, and one more time integration. So e raised to minus x upon minus 1 plus c, constant of the integration. Now everywhere you have e raised to minus x. So let's divide by that. So y, this is nothing but the 5 minus x here. This is minus here 1 plus c into dividing by this. So e raised to x. Call this as 1. Why we are getting e raised to x? It's like this, remember here. It is like c upon e raised to minus x. So it will be c into e raised to x. Okay, now you are given that as it passes through, this curve passes through, this is a general curve, remember, passes through 0, 2. So put x equals to 0 and y equals to 2 in above equation. So by 1, y 2, x 0, so 5 minus 1, you have c into e raised to 0. So what we'll get from this? Here c equals to, you will get minus 2, remember. So therefore finally the curve which is in fact which solution? Particular solution by 1. Y equals to 5 minus x minus 1 minus 2 into e raised to x, and therefore finally y equals to 4 minus x 2 times e raised to minus x. This is nothing but the final curve in the given question number 17. That's a required curve. Y equals to 4 minus x minus 2 into e raised to x. Fine? Okay. Question number 19. That's just an MCQ. You must have noticed that that's not a standard linear differential equation, because standard linear differential equation never contains y square. 1 minus y square into dx by dy plus y into x equals to ay. This is not the standard linear differential equation. It's that corresponding. So we need to express in which form? Just recall dx by dy plus p into यहाँ पे x है तो x equals to q. That's what you need to do. So I'll divide by this. Coefficient should be 1 as we know. So dx by dy plus x. So y upon 1 minus y square into x equals to ay upon 1 minus y square. Now it is in this form. Right? It is in which form? dx by dy plus p into y equals to q form. Now this is nothing but p. This is p as per our standard notation, and this is q. We don't want here remember q. We want just integrating factor. So here if equals to e raised to integral of p with respect to x. So e raised to y upon 1 minus y square dy. Now how will integrate this? Linear upon quadratic. Set the derivative. What's the derivative? Minus 2y. So multiplying and dividing with minus 2. So here minus 2. This is minus 2y upon 1 minus y square dy. Now this is f dash upon f form. So here e raised to minus 1 by 2 log of here mod of 1 minus y square. You know very well. Now these two will get cancelled if that coefficient is in power. So ये power में जाना चाहिए, remember. This will go in power. So e raised to log of nothing means base is e, remember. 1 minus y square raised to minus 1 by 2. Now this 2 will get cancelled. So 1 minus y square raised to minus 1 by 2. You know this e raised to log x to the base e is just x. That you know very well. Okay, and this is 1 upon with root 1 minus y square. So that's your required integrating factor, which is nothing but the option D, remember. So we'll go for now miscellaneous exercise. That's just recap of entire chapter. The question number 1, first one, you are asked for order and degree. So which is highest order derivative? 2. So order will be 2. You can see that d square y by dx squared is present. So order will be 2. Degree किसका देखेंगे आप लोग? Exponent of d square y by dx square. इसका power देखना आपको. There is nothing means 1 here. So degree is 1. Remember, don't get confused. मैंने आपको आगे बोला था कि log एक्सपोनेंशियल ट्रिगो या इन्वर्स ट्रिगो अंदर dy बाई dx के साथ कंपोजिशन नहीं होना चाहिए, है ना. log इज देयर, स्टिल डिग्री इज डिफाइंड, रिमेंबर हियर. ऐसा नहीं होना चाहिए. log ऑफ dy बाई dx, इफ यू हैव लाइक दिस देन डिग्री इज नॉट डिफाइंड. कीप इन योर माइंड, डोंट गेट कंफ्यूज्ड. कम टू नेक्स्ट क्वेश्चन, सेकेंड वन. व्हाट इज हाईएस्ट ऑर्डर डेरिवेटिव? एक ही है. सो अब देखो dy बाई dx ही है. सो ऑर्डर विल बी 1. ठीक है. व्हाट अबाउट द डिग्री? दैट्स ऑब्वियस नाउ. डिग्री विल बी व्हाट? हाईएस्ट ऑर्डर. किसका देखना है आपको? जिसका आपने ऑर्डर देखा उसका. सो आपके पास dy बाई dx द होल क्यूब है, देखो अंदर 3 है. सो द डिग्री विल बी 3. साइन x इज देयर बट साइन ऑफ dy बाई dx होता तो डिग्री अनडिफाइंड हो जाता. अगर ऐसा होता देन डिग्री इज इन दिस केस डिग्री इज नॉट डिफाइंड. रिमेंबर, okay, in this case the degree is not defined. Fine. Okay, third one. Now you can see there order milega. Order has nothing to do with trigo and so on. What's the order of this differential equation? Order will be 4. Highest order derivative under d raised to 4 y by dx raised to 4 है. So order will be 4. What about degree? Degree is not defined here. Degree नहीं मिलेगा. क्यों? Degree not defined. This should be clear to you because this is not a polynomial in dy by dx. क्यों? क्योंकि डेरिवेटिव का किसके साथ कंपोजिशन है? साइन के साथ है, इसलिए. So therefore degree is not defined. Clear? Okay. Question number 2 is purely from differentiation. आपके पास लेफ्ट हैंड साइड सॉल्यूशन है, राइट हैंड साइड पे डिफरेंशियल इक्वेशन है. क्या करना है? वेरीफाई करना है. So what you need to do, get all required derivatives from the left hand side, then put into the left hand side of differential equation. Notice that you are getting 0, that much only. Okay, we had complete exercise earlier. Question number 2, first one. Right, you want to verify the equation that is written on the left hand side is a solution of the differential equation given on the right hand side. Okay, so what is the method? You get all required derivatives from this equation and you show that the derivatives satisfy the given differential equation. Satisfy the given differential equation means what? All derivatives when you place on the left hand side of the differential equation you must get the RHS, that is the right hand side. Okay, so now we just differentiate it. Differentiating, you know how to do this. This is just question of differentiation. What is left hand side? You have product of two functions, x as it is into dy by dx, y as it is, derivative of x is 1, a being constant as it is, differentiation of e raised to x is e raised to x. Then here b being constant as it is, what's the derivative of e raised to minus x? E raised to x minus x into minus 1 plus 2x. Fine. This is simply differentiation. Again we'll do the differentiation. Again differentiating. 2 times you need to do. Why you need to do 2 times? Because right hand side पे जो differential equation दिख रहा है उसमें d square y by dx square है, remember. Okay. So again I'll differentiate this. Product rule on the left hand side. X as it is, here you have d square y by dx square plus now dy by dx as it is, differentiation of x1, a being constant as it is, derivative of e raised to x is e raised to x, b being constant as it is, differentiation of e raised to minus x is e raised to minus x upon minus 1. So plus 2. Right, now 2 times differentiation is over. Now here one way is you can put dy by dx, d square by dx square on the left hand side and you can just show that it is 0. The another way is use first 2 equations and you make this equation free from a and b, where a and b are arbitrary constants. So you'll get that equation. You can call this as 1, for example. You can call this as 2 if you want. Right? Now what I'll do, I'll just place the value of this one from 1, right? So from 1, let me call this as 3. So from 1, a into e raised to x plus b into e raised to minus x equals to xy minus x squared, right? This is from 1. I'm placing this one over here. So x into d square y by dx square plus dy by dx equals to, placing the value of this much. What is that? xy minus x squared plus 2 as it is. And you can see that that's your required differential equation. We had earlier such questions, if you remember. What I did, I've just eliminated a and b from the last differential equation. Remember, I did nothing with the help of one, which is required differential equation. Required differential equation. Right? You just need to recall one of the earlier exercise. That was probably, can you just recall it was which exercise where we did such things? It was exercise 9.3. Just recall such things you did in exercise 9.3. You had many such questions. Fine? Okay. Now we go to next. So you must have realized this is simply differentiation, remember. What about next question? Question number, let's do इसका second करवा रहा हूँ. Second question here. You are given y equals to e raised to x into a cosine x plus b sin x. What we want to do? We want to show that this is a solution of given differential equation on the right hand side. That means from these equation you want to get that differential equation. That's the indirectly question, and that was 9.3 exercise if you remember. So we do differentiation. How many times? 2 times. वहाँ पे तो आपको दिख भी रहा है डी स्क्वायर वाई बाई डी एक्स स्क्वायर है. अदरवाइज आपको पता भी है कि यहाँ पे 2 आर्बिट्ररी कांस्टेंट है तो 2 बार डिफरेंशिएशन करना चाहिए. दैट यू नो. सो डिफरेंशिएटिंग ट्वाइस. लेट्स डू 1 टाइम. सो डी वाई बाई डी एक्स, right hand side product rule, remember. Which rule? Product rule. Differentiation of e raised to x, e raised to x. The bracket as it is, a cos x plus b sin x. Plus, now here e raised to x as it is, a bracket ka differentiation. A being constant as it is, what's the derivative of cos? Minus sin. Plus b being constant as it is, what's the derivative of sin x cos x? We did differentiation once here. Now before I do again differentiation, see this is nothing but y by 1, you see, so I'll just place y and this one as it is right now. Okay, we are doing nothing with this. Okay, this much is y. Just to make the differentiation easier, I'll write by 1 here. By 1, just I'll write by 1. Call this as 2, equation number 2. Now we'll go for differentiation. Okay, so again I'm differentiating. So again differentiation. So left hand side again differentiating. D square y by dx square. What about right hand side? Derivative of y. Have a look on the previous step. Dy by dx plus. Now product rule for the second term. E raised to x as it is, वो ब्रैकेट का डेरिवेटिव मैं कर रहा हूँ, माइनस ए डिफरेंशिएशन ऑफ साइन इज कोस एक्स प्लस बी एज इट इज एंड कोस का डेरिवेटिव माइनस साइन, तो मैं यहाँ पे आगे माइनस कर दूँ इनटू साइन एक्स प्लस नाउ डिफरेंशिएशन ऑफ e raised to x as it is, डिफरेंशिएशन ऑफ e raised to x, e raised to x and that bracket as it is. Remember, we are doing nothing with that bracket. So differentiation is over now. You must have noticed why you have 2 terms there from that e raised to x. This one as it is, bracket का differentiation किया तो इतना है. अब e raised to x का derivative and that bracket as it is, remember. Now we need to use the earlier equations and we need to simplify. ये आपको पता है माइनस कॉमन ले लो तो y हो जाएगा. d square y by dx square equals to dy by dx plus you take minus common, so this is just minus y. Have a look at the 1. ये पूरा minus y है और ये जो expression का value है that will come from 2. Have a look on 2. So the last term का जो value दिख रहा है आपको, the value of that last term will be क्या होगा? dy by dx minus y. This is from 2. This is from equation 2, previous equation, and this is from equation 1. Fine. बस तो हो गया. That's what the required differential equation. D square y by dx square. This will be double here, and I'll take on the left hand side. So minus 2 times dy by dx plus 2y equals to 0. Right? Required differential equation. Exercise 9.3 आपको याद करना है. Or you could have done like this also, remember, if you feel that this is easier. क्या करना है? You now start with, this may not be every time possible. Now start with LHS of differential equation. क्या है LHS? D square y by dx square minus 2 times dy by dx plus 2y. Okay. Now here what you can do, you place the value of what? D square y by dx square. कहाँ है? A रहा. Right? Place here. Minus 2 as it is. Place the value of dy by dx. वो आपको पता है. Where is the value of dy by dx? Look at it, equation number 2. You place here. Plus 2y as it is. You simplify, you will notice that this becomes 0, and which is RHS. And therefore, you can say that derivatives obtained from this equation satisfy the given differential equation, and therefore it's a solution. Fine. Okay. Now, third, fourth you can try. It's basically question of differentiation indirectly. I'll go to question number 3, main third question. This is the repetition of exercise, as I told you. Which exercise? 9.3, remember. Third, fourth and fifth. This is just exercise 9.3 और कुछ नहीं है. And this is again, the entire 9.3 is very good exercise, remember. Okay, question number 3, third one. Form the differential equation. यहाँ पे differential equation आपको नहीं दिख रहा है. Previous question में दिख रहा था, remember. Okay, so you know how to do this. X minus a the whole square plus 2y square equals to a square. Where आपको बोल दिया a is a or b constant. What is a? That is arbitrary constant. Small a is nothing but what? Arbitrary constant. Now यहाँ पे differential equation नहीं है, तो आप कितनी बार differentiation करेंगे? एक बार, because there is only one arbitrary constant. And जो differential equation मिलेगा उसमें से a निकल जाना चाहिए, remember. So we just differentiate this. Differentiating. Okay. Chain rule. So twice x minus a into derivative of this, which is 1 minus 0. 2 as it is. What's the derivative of y square? 2y into dy by dx. 2y into dy by dx. Chain rule. What is this? A square being constant 0. Fine. You can divide by 2 at least. So x minus a here plus 2y into dy by dx equals to 0. So you have now value of a at least. You have equation number 1, the other one is 2. What we do? We use these two and we make the equation free from a. Fine. So what I'll do is, here I'll place the value of, remember, x minus a, which is this much, and here I'll place the value of a. Okay, so using, let me write, using 2 from 1, from equation 1, we get this. What we get? x minus a का value कितना होगा? Minus 2y into dy by dx the whole square. x माइनस ए का वैल्यू कितना होगा? माइनस 2y इंटू डी वाई बाई डी एक्स होल स्क्वायर यहाँ पे प्लेस कर दिया, प्लस 2y स्क्वायर एज इट इज. नाउ आई नीड जस्ट a, so I'll get a from this. What is a from this? इसको इस साइड ले लो, तो x plus 2y into dy by dx. I hope this is clear to you. What I did, मैंने just a find किया. Take a over here. So x plus 2y into dy by dx whole squared. Square कर दो. Right? Now देखो. Of course we need to simplify this. but this equation is free from a. Remember, once we simplify, it's a required differential equation. So let me just simplify this. This is 4y squared d square y by dx square plus 2y square. Here I'll open the bracket like a plus b the whole square. So this is x square plus, what is this, 4xy into dy by dx plus 4y square d square y by dx square. So this will get cancelled. So you will get finally x squared plus 4xy into dy by dx minus 2y square equals to 0. This is the required differential equation. I hope you must be clear with this. I did nothing, just one time differentiation. ये दोनों यूज करके a equation में से small a को हटा दिया. Remember, nothing more than that you did. Whichever way you like. It's not necessary you should do like this. The concept is this. Differential equation should be free from arbitrary constant. Right? That is exercise 9.3. Puri exercise important है. You might have noticed. Okay. Question number 4 I'll not do because you know there आपको डिफरेंशियल इक्वेशन दे दिया सामने. सो यू कैन डू विच ओवर वे यू लाइक. आप इंटीग्रेशन से भी कर सकते हैं, रिमेंबर, और आप डिफरेंशिएशन से भी कर सकते हैं. प्रूव दैट दिस इज द जनरल सॉल्यूशन ऑफ दिस डिफरेंशियल इक्वेशन. सो व्हाट यू कैन डू, यू स्टार्ट विद डिफरेंशियल इक्वेशन एंड इंटीग्रेटेड. आप केयरफुली देखेंगे तो होमोजेनियस डिफरेंशियल इक्वेशन है. यूज दैट टेक्निक सो विल गेट दैट सॉल्यूशन. दैट इज वन वे. The another way is, what is the another way? वो इक्वेशन से चालू करो, डिफरेंशिएशन करके देखो इतना मिलना चाहिए. Right? The whichever way you feel easier, remember. But don't leave that sum. Try, you must try. Fourth I'm not doing. It's good example. I repeat the solution. What you need to do? Start with the differential equation. आपको differential equation दिख रहा है. आप देखेंगे तो वो होमोजीनियस डिफरेंशियल इक्वेशन है. क्यों पता चला होमोजीनियस डिफरेंशियल इक्वेशन है? यू सी डिग्री और द पावर ऑफ ईच टर्म इज देयर हाउ मच? 3. रिमेंबर, 3 3 3. So it's a homogeneous differential equation. So use the method, get the dy by dx first, put y by x equals to v if you remember, right? Then y equals to vx, and then just simplify and do further. So आपको मिलना चाहिए. Or you can do reverse also. What's the reverse procedure? Solution से चालू करके as you did in the question number 2 आपको differential equation ले लो. तो fourth जो है वो question 2 जैसा ही है, main 2. So I'm sure you can do that. Okay, I'll go to question number 5, fifth one. That's also a nice example. So in the fifth question, form the differential equation of the family of circles in the first quadrant which touches both the axes. So first we need to get the equation of circle that touches both the axes in the first quadrant. So here x-axis, y-axis, we have circle in the first quadrant touching both the axes. So the circle will be like this. It would touch both the coordinate axes. So if this is the center of the circle, this you know represent the radius. These also we know radius. So what is the coordinates of the center? R comma R, remember. And R will be positive because it is in the first quadrant. Right? So your center of the circle will be R comma R. And what's the radius? Radius is here small r. And R is positive here because it's a radius, as well as these two are also positive because your center is on the first quadrant. When circle touches both the coordinate axes, then this represent height represent radius, this also represent 1 1. So here 1 comma 1, 2 2. Remember, it touches both the axes, then it has to be this. So then you can write the equation of the circle. Equation of the circle. You know how to write the equation of the circle. X minus h the whole square, that is r square, plus y minus k the whole square, so r square, equals to, you have r square, remember here. Fine, this is the equation of the circle. X minus h the whole square plus y minus k the whole square equals to r square. Call this as equation number 1. Where what is r? R is arbitrary constant. एक ही arbitrary constant है. Okay, r can be 1 1, r can be 2 2. So you will get the many circles, but all circles will touches both the axes. Remember. Now we differentiated how many times? One time. Now it's the beginning of the previous question. Our previous question चालू हो गया, remember. That is question number 3 or 4, जो भी बोला. So we differentiated once only. Why we differentiated one time only? Because it has only one arbitrary constant. Differentiating once. Okay. So let me differentiate it. What about left hand side here? Chain rule. 2 times x minus r the whole square into derivative of this, which is 1. 2 times y minus r the whole square into derivative of this, which is y dash minus 0, equals to 0. Can divide by 2 here. So if I divide by 2, x minus r the whole square plus y minus r the whole square into y dash equals to 0. Dividing by, oh sorry, I'm sorry here, this is wrong. ये 2 नहीं आएगा. Derivative of x square is 2x. I'm sorry. So let me rewrite this equation. So you have x minus r plus y minus r into y dash equals to 0. That is required differential equation only when it is free from r. Remember, r nahi hona chahiye because it's arbitrary constant. Right? You can call this as equation number 2. Now what you need to do, as I did in the previous example, use 1 and 2 and make the equation free from r. That's what we want to do now. So from this equation, from 2, you can find r very easily. X minus r y dash minus ry dash equals to 0. I hope you are clear that what I am doing. I want to make this equation free from r. So I need to use the equation number 1, remember, as I did in the example number 3. So here x plus y dash. Take this 2 on the other side and take r common. 1 plus y dash into r. Taking these two expressions on the other side. And therefore, here what is r? X plus y dash upon 1 plus y dash. This is r. Now putting this in equation 1, putting r in 1 in equation number 1. Right. So we'll get the required differential equation. So मैं 1 में place कर रहा हूँ. Have a look at 1. X minus x plus y dash upon 1 plus y dash the whole square. यहाँ पे पूरा square तो है ही, remember, the whole square, plus here y minus what is r? X plus y dash upon 1 plus y dash and then whole square equals to here x plus y dash upon 1 plus y dash the whole square. Everywhere I place the value of what? R. Okay. Now you see this will go over here, this will go over here, and then that will get cancelled from both the sides. So you have x plus xy dash minus x minus y dash the whole square. Just notice this here, y plus y dash minus x minus y dash, and right hand side is x plus y dash the whole square. यहाँ पे भी square है, here also whole square. The denominator, after taking cancel, After taking LCM, it will get cancelled from both the sides. So this will get cancelled, this will get cancelled. So here y dash into x minus y the whole square. What about this? Here y minus x the whole square equals to x plus y dash the whole square. And now last step, you can take y minus x the whole square common. आप इतना common ले सकते हैं, square है नहीं तो x minus y or y minus x is not important. So here y dash square plus 1 equals to x plus y dash the whole square. This is a required differential equation, remember. This is required differential equation. Okay? What is that equation? X plus y dash the whole square. Your x minus y or y minus x, both are same because you're whole square, into 1 plus y dash the whole square. This is the required differential equation. What is important one here, just making the final differential equation free from that r, that is arbitrary constant. That's only important thing. In the first step you did nothing, just differentiation, remember. Fine. Okay. Now question number 6th onwards we want to do reverse. 6th, 7th, in all these questions you have differential equations and we'll solve them. So far you know you have used what? Differentiation, and now onwards we use integration. So let me go for which question? Question number 6.